Hello everyone. In this video, we will discuss about the electrical vehicle charging station when falls occurs at the distribution side. And in this present scenario, you already know that electrical vehicles have a great demand, right? So according to the Ministry of Power, there is a MOU regarding to electrical vehicles to spread 2023 electrical vehicle expansion. Regarding to those dishes, you just follow this one. You can get the details. So in this project, we need to analyze the critical voltage conditions rises at the distribution side. So this is the basic diagram regarding to the proposed design. So in this design, this one is the distribution grid. You already know distribution grid is affected to the voltage transient, voltage disturbances. All these things will be rises at this terminal. So in order to protect the device, we need to place an accurate device to compensate the voltage power quality problems. So in order to do that one, we are preferring this one. This one is the DVR here. Why I connected DVR here means whenever fault occurs in the distribution side through the charging station, that means this is the electrical vehicle charging station. So in order to protect the electrical vehicles, charging and discharging condition of the electrical vehicle totally depends upon the at this terminal voltage, right? So at this terminal voltage, if voltage does not having any voltage related problems means automatically the electrical vehicle charging station whatever you preferring that is safe. Suppose these power quality issues, whatever voltage or power quality issues rises at this point means definitely they will affect the charging behavior of the electrical vehicle. So in order to protect the electrical vehicle, we just simply mention the DVR to protect the device. This is the synchronous reference frame theory. We are going to prefer to run the inverter. Okay. And in this design, inverter role is to convert AC to DC. Why? Because you already know battery requires DC only, right? For that purpose, we are using AC to DC conversion. I will run the model. This is the model regarding to that design. So in this design, here the electrical vehicle battery is exist. This one is the distribution side. Suppose in order to create any voltage sag, swell, harmonics means we can create inside of this block. Okay. So three-phase programmable voltage source can create you voltage sag, swell, and harmonics. Suppose without DVR, okay, without DVR, let's assume this entire up to now what I highlighted, this entire block is not available right now. Okay, I am creating sag here by mentioning these parameter. So without this DVR means whatever the generating sag will be going through this terminal. That means this terminal also affect by the voltage sag. Then that affects the battery characteristics. Why? Because if voltage reduce means automatically DC link voltage is reduced. So DC link voltage reduce means the charging and discharging behavior of the battery will affect, right? So this is the main thing we need to protect, right? So in order to protect the device, definitely we require good voltage related data. For that reason only we prefer the DVR here. So this is the DVR structure. You already know regarding to DVR all this data. Here we can replace with any DC power generation source, either solar, wind, battery, or any other parameter. You can take, no problem. So DVR is a stabilizer, voltage stabilizer. We need a DC generating source that can inject compensating voltage to the whatever the voltage sag occurring here. And this is the control strategy. This control strategy name is synchronous reference frame theory. Here, whatever the error obtained, we are comparing two loads here. I mean, two voltage parameters. One is VL minus VABC. Why I taken these two parameters means I want to know first of all how much compensating voltage we need to inject from the DVR, right? For that reason, we select these two terminals: load voltage minus sending end voltage. So suppose there is an any steady state error means we need to reduce the steady state error. How we can reduce the steady state error? With the help of the PI controllers only. So that's why we preferred PI controllers. Whatever the compensating voltage given to the pulse width modulation. So when there is a voltage difference between sending end to the load end, at that time only that we are going to inject the voltage. That is the role of the DVR here. So apart from this one, this is the this AC voltage. Here electrical vehicle present, right? So for electrical vehicle, we require only DC. For that reason, we are initially converting AC to DC. This is the inverter part to convert AC to DC. Okay. For conversion of DC, battery required constant DC parameter, right? I mean, either if it want to charge and discharge, it requires constant DC only. But whatever the obtained here, DC is compensate, I mean, fluctuating DC, right? So in order to control the fluctuations in the DC, we are creating a voltage controlling loop to control the voltage here. And then current controlling loop is given to maintain current levels of the battery. That means charging and discharging behavior of the battery can be controlled by the this outer current controlling loop. This is inner voltage controlling loop, and this one is the outer current controlling loop. Overall, this one is given to the pulse width modulation. Why again I am using pulse width modulation means here switches available at the AC to DC conversion, and then DC to DC conversion also having switches, right? For that purpose also we require another control strategy. So in this proposed model, we having overall three control strategies. One is, see here, one is rectifier control. This is the rectifier control strategy. Another one is the chopper control strategy. Another one is the DVR control strategy. So overall three control strategies required. Why I'm using this much of control strategies? In order to protect the electrical vehicle charging station regarding to fault time intervals. So how we protect the faulty cases from the distribution grid means with the help of the DVR. DVR have the capability to fault right through the condition. Okay, that is the advantage using this control strategy here. For research scholars, you just replace any new control strategy here in the DVR control strategy. Either if you take LMS control strategy or any adaptive filter type, or else you can use Sogi Fugi type. In this one, I didn't discuss about any harmonics, right? So if you can create here voltage sag swell harmonics also. But DVR cannot. I mean, synchronous reference frame theory cannot accurately reduce the harmonics, right? That is the disadvantage. You can replace with this control topology with another control topology to improve the characteristics of the DVR. That is the role for the PhD scholar to enhance the performance of the DVR. Okay. So in this project, I only discuss about the percentage of the sags only. You can replace with different voltage sags, well, and harmonics. That will create a uh, uh, new research paper for the PhD scholars. Okay. So I just discussed here only 30, 60, and 90 sag percentages, and remaining are the characteristics of the battery and state of charge, battery current, all these things. I will show you in simulation model. See here, this paper is published in June 2022. Okay. So recent publication paper. So whoever the research persons, you can focus this one, can get a new research paper easily within short interval. Okay. This is my point of view. It can help you in your research. Okay. Now I will show you result. I just show you one case. Remaining all designs you can show you later. Okay. Why? Because one model it will takes nearly 20 to 15 minutes. 20 to I mean 15 to 20 minutes. Wait for a few seconds to complete this simulation model. And how the DC link voltage will be varying here. You need to point out this one. Why? Because if you maintain DC link constant only at the time, the charging behavior of the battery will be good. Are you observing here? At 0.18 or 18 second, when sag will be occurs at the time, the DC will be fluctuate. Exactly, DC will be fluctuate. Why? Because the sag will be there, right? So in order to mitigate these fluctuations, we required accurate control over the inverter part. Then only the DC fluctuations will be within the limit. See here, the voltage fluctuations here will be nearly above the tolerance band, right? When you taken DC fluctuations, with it having only some, I mean, 2 to 3% tolerance band. That means, for example, if you take 700 as a DC input, so tolerance band means only 2% of the 700 voltage. It exactly nearer to 30 to 40 voltage. In between that range only tolerance band. But when you observe here, it will, I mean, it will not prohibit the voltage within the limits. It already enhanced the different voltages, right? That means the fluctuations will be more than whatever we expected. That is the main disadvantage in the electrical vehicles. Suppose the distribution grid doesn't having good voltage means that definitely going to hurt the electrical vehicle. That means that any damages in the electrical vehicle. Hope you this project can help you regarding to research scholars to done a new novel project. I will show you results here. So these are the results regarding to the 30% of sag with sending end voltage, receiving end voltage, injecting voltage, DC-link voltage, remaining battery parameters characteristics. Okay. Thank you for watching this video.